In this first video, we are going to talk about many of the basics in helping us get started with our AP review. First of all, let's just familiarize ourselves with different terminology that will be used during AP questions. You'll see these two different fonts that will be used. The Courier New font will be used for code, and this italicized, sometimes bold, font will be used for pseudocode. When we're looking at documentation, we will see the Javadoc comment style, the @param, @return, and @throws. We'll see this sometimes, and then other times we'll see the precondition, postcondition terminology. The precondition, postcondition is something that some students are a little bit less familiar with, and basically the precondition tells us what we can assume entering the method. So for example, it might say the precondition is that all values are positive numbers. And then that means you can assume that there's no negative values there or no zeros. Postcondition is everything that must be true when we leave the method. Identifier rules. We want to make sure we are comfortable with all of the different rules for naming variables, parameters, constants, methods, or class names. So we can have letters, digits, or underscores. We cannot begin with a digit. And names are case sensitive. They should be self-documenting, meaning that they should describe what they are. In terms of conventions, we want to use camel case, and variables and methods should begin with a lowercase, and class names should begin with a capital letter. Constants should be all caps. And remember that there are some of those reserved words as well. Primitive data types. There are, I believe, 8 primitive data types, but the AP test only tests your knowledge on int, boolean, and double. We can use a cast to convert between different data types. If you're going to go from an int to a double, this does not require a cast. Basically what will happen is a .0 will be added on to the end. If you're going to go from an double to an int, this does require a cast because in this case you'll be losing part of the data. So if you take a look at these two different examples that I gave you, here we started out with an integer value of 2, and then we sorted into a double variable. And in this case, when that integer was sorted into a double, it just turned the value into 2.0. We did not need a cast. In this second example, we had a double value, 5.7, and we wanted to store it into an integer. Oh, there should have been a semicolon there. Oops. And when we wanted to store this into an integer, this requires a cast. And the reason why a cast is required is because we need to tell the computer that we recognize that some of the data is going to be truncated and we are accepting that and we are okay with it. So when you go from an int to a double to an int, all decimal point is lost. Even if it was 0.99, it does not round up. It completely truncates, meaning that it chops it off. Constants are final variables. These are variables whose values will never change, and naming convention tells us to put them in all caps. We use the keyword final to tell the compiler that we are creating a constant, and it's possible that we can create a constant without giving it initial value. However, once we give this constant a value, the value can't be changed. An example where this might occur is, let's say, for example, we wanted to have a value where the user would determine which tax rate we would want to use. So maybe we were determining if we were a non-for-profit, for example, and if we were a regular consumer, we would have a tax rate. If we were a non-for-profit, we would not have a tax rate because you would be tax exempt. So in that case, our tax rate would be 0.0. And but once that tax rate is given, it cannot be changed. This is something that we could do if needed. A common way that constants are used are for the size of an array, because as we know, the array size is not changeable. And another pro to a constant is that where they're usually listed at the top of our program, and it makes code revisions much easier because you only have to look at the top of the program to find out where those constants are to change them. All right, when we're looking at our arithmetic operators, so these are our different operators, the plus, minus, multiply, divide, and the modulus. And these can be applied to both ints and doubles. And if the arithmetic contains an int and a double, then the answer is promoted, which means that the answer is turned into a double in the end. The percent modulator finds the remainder when two values are divided. It's important to remember that if the first number is smaller than the second number, then what happens is that it divides in 0 times. So in this case, 3% 10 divides in 0 times with the remainder of 3. A lot of times people get that one wrong. You can also do percent with doubles, but a lot of times people forget about that because we don't see it very often. When we're dealing with division with integers, we need to remember that it does truncate, and if at least one value is a double, then the answer will be a double with no truncation. We can also use casting so that we can control the type of the answer. So you'll see here in these two cases, since one of the operands was a double, the answer is a double. In this case, since this was casted to an int first, int with int gives us an int answer. Here, since this was casted to a double first, double with an int gives me a double answer. And then in this case, this is a commonly missed problem. The division is done first. So this division is done, the answer is turned into 0, and then 0 is turned into a double, which is why the answer here is 0.0. When we are looking at our relational operators, that is comparing things, and these comparisons can only be done with primitive values, ints, doubles, and booleans. If we're comparing objects, then we need to use the equals or the compare to method. The two vertical bars is the or, and the two ands is the and. And with an or statement, it requires only one of the statements to be true. And with an and requires both statements to be true. We have what is called short circuit evaluation. And short circuit evaluation is going to go from left to right. And essentially what's going to happen is if the leftmost expression in an OR is true, then the true is automatically returned and the second condition is not even checked. If we're dealing with an AND statement, if the leftmost expression is false, then the false is automatically returned and the right isn't even checked. So short circuit evaluation is a kind of like, again, a shortcut for the computer in doing these comparisons, and it can be used, if used effectively, it can help you to avoid a divide by zero error, a null pointer error, index out of bounds, etc., because you can have that check done as the first statement of an and then if it's valid, then you can go ahead and do whatever other scenario you need to do. We have our increment, our plus plus, or our minus minus, and we have what's called a postfix and a prefix. And most people typically use the postfix operator. A lot of people don't even realize that the prefix operator exists. I haven't really seen it used much on the AP test, but I figured it was worth a quick mention. In general, they have the equivalent operation that they increase by 1. However, they do it at different times. So, and this is the same for the minus minus. So you'll see here in these two different examples, in both cases, I and j start out as 4. If I were to do I++ and I were to print that, what would happen is this would print 4, and then it would increase it to be equal to 5. In this case, if I were to do ++ j, this would increase j to be 5, and then it would print out the 5. So it's just a small little detail. Again, we don't typically see this, but I just figured I would mention it. All right, in terms of order of operations, so this right here lists out our order of precedence. The not in the plus plus and the minus minus, that happens first. And then we have our multiply, divide, modulus, add, subtract. Then we have all of our comparisons, our equals, equals, not equals to, and then and, or, and then we have finally these assignment operators. So everything here goes from left to right on these top things up here, and then the operators here from right to left. So what this means when it says from right to left is that we essentially evaluate whatever is on the right and assign it into the left. So if I were to say that I have something over here, it's going to do whatever is over here on the right and then assign it back into the left. That's what I mean by this over here in this last bullet point. Okay, in terms of input-output is not really something that's tested on the Java AP subset because there's so many ways that we can use input. We don't use the scanner class. We're not going to use buffered readers or read text files or anything like that. Excuse me. Instead, what you'll see is something like this where we have just this general method, they'll say read double or get int or something like that. And they'll say that this is something that's done just to get a value. And in terms of output, output is restricted to system.out.print or println. And remember that the abbreviation that we use in class, the SOP and the SOPLN, that's just kind of a demo thing. That's not an AP abbreviation, so you don't want to use that on your FRQs. You're not tested on formatted output. We also want to understand that the toString method is used to print an object's value or state. Without a toString method, the address of memory will be printed. These are the escape sequences you want to be comfortable with to get a new line, to print double quote, and to print a backslash. In terms of our control structures, we have if-else, our nested if, and it's just important to realize that if we have this nested if, that's the same thing as just doing an and statement. We also want to be careful of this dangling else statement. An else is always paired with the closest if, so regardless of any indentation. So just be careful when you're reading your code that you always want to look that else is going to match up with the if right above it, unless there are curly braces to force it to match up otherwise. All right, so with our for and our while loops, with these loops, the terminating condition is tested at the top of the loop, and the update statement is performed at the bottom of the loop. The for loop control variable, the loop that is the variable that controls this loop up top, should not have its value changed inside the loop body. That really goes against the way that it should be done. If that loop is initialized in the for loop, then its value will not exist outside the for loop. If it's initialized before the loop, then it will still exist after. So what I mean by that is if you were to say for int I equals 0, in that case that variable only exists within the loop. It's possible for a loop to never happen if this for statement, if this initialization, if this condition isn't true, then it will never occur. If the loop is never false, then you're going to have an infinite loop. Now your for each loop. So this is useful when you want to iterate through a whole collection. It's going to go through every element from the beginning to the end. And we'll talk about this more when we get in our arrays lesson. And essentially our notation is going to say, if we have this array, you're going to say for, you'll say the type of value, give it a temporary name, colon the array name. So notice the array name was ARR, the data type of the array was int, and then element is just a temporary variable name. And then now I'm going to print element. So every time through the loop, element will be equal to entry 0, then entry 1, entry 2, and so on. Last but not least, we have these different errors and exceptions that you should know. So there are tons of exceptions that we'll encounter in our Java coding. These are the ones that they expect you to know on the AP test. So most commonly that we see is the null pointer exception, and this happens when we try to refer to an object that we have not instantiated yet. So the reference literally points to nothing. Another one that happens that we see a lot is the array index out of bounds or index out of bounds. And this happens if we try to go beyond the size of the array. So if your loop goes one too far, or if you try to access an index of -1, those are common errors there. All right, so we will continue with these different review lessons, but this was our first one, and thank you.